Hello, my name is Jake, and I am one of the senior geoscientists here at Elise. This video will cover the Relative Geological Time Model creation and editing. Now, if you're visiting us via our YouTube channel, please be sure to subscribe. That way you'll be notified whenever we post new tutorials. And if you find this video educational, please get a thumbs up and click on that like button. So thanks for joining. Let's get started. Now, the model grid to GeoModel creation is a workflow that's really unique to PaleoScan. So it's important to understand how to set up and edit the model grid in order to ensure the generation of a geomodel or RGT volume that accurately mimics the seismic used as input. So besides seismic, we can also use horizons and faults to constrain our model grid before we edit it to create our geomodel. Now, it's important that we spend a bit of time editing our model grid so that our patches and horizons and relative age relationship given to each of the patches within the model grid accurately follows the seismic, so that when we extract our horizon stacks from that geomodel, they are structurally accurate and ensure that the correct attributes are mapped onto them. This is also important as a part of our geobody extraction workflow. So this video will cover how to create the model grid, how we edit or alter the model grid so that it fits or matches the seismic so that we can create a very accurate geomodel creation. And the reason that has to be so accurate is because we are going to extract our horizons from this relative age volume. So we'll be covering those four main attributes of the software in this video. Okay, so we're looking at the main PaleoScan workspace. And to create a new model grid, make sure you are on your model grid toolbar from your module selection toolbar. Click on New and select New 3D Model Grid. Now we can also create a model grid from 2D lines, but that's a topic for another video. Once that dialog box opens, click on the seismic that you want to use as an input. Set a focal point by holding down your primary mouse button and dragging your cursor on the seismic image. Make sure that cross navigation mode is turned on first. And then come down and click on Test Parameters. So software is going to now run through, and it's going to give us a preview of what the geomodel would look like if we were to use just these parameters that are defaulted, right? So there's a couple ways to alter the preview that we're showing as this image. So you'll see in my properties pane, if I turn off the model preview, that will remove the overlay for my seismic window. I can turn on an ISO line, and this is just a chronostratigraphic ISO line that's following that age relationship that would be created using these default parameters. Now, finally, what we can do is turn on the actual grid to get a look at what those grid nodes would look like. So here's just a quick example of this grid that the software creates based on the parameters. Now you'll see, let's talk about these parameters, right? So the patch size refers to how many traces we're going to skip before reading another trace and placing nodes on the polarity that we've selected, right? So as a rule of thumb, if you've got really simple geology, flat lying, you could probably increase that patch size. The software is going to still be able to make connections if you don't have things jumping around a lot. However, if you have very structurally complex geology, you'll find that you'll probably want to reduce that number in order to help the software jump from one trace to the next and continue to make those connections accurately. All right, and so that's the first parameter that we want to consider when we're building a model grid. Now, the other one is the polarity. So this is in reference to your vertical resolution. So we do have a number of different options, and this is all going to be very specific to your data type. But in general, you'll find that you want to increase the density with depth just because of the loss of frequency through attenuation. So if you're working in very deep basins, increasing the amount of vertical polarity or vertical resolution is probably a good idea. However, if you're working in very shallow, shallow hazard type work, it's likely that just peak trough or zero crossing by itself is probably going to be fine. Now, once you've decided on the patch size and the polarity, by changing those and then testing your parameters over and over again and just trying to see what gives you the best connections, now we'll move on to the smooth level. Now, the smoothing level can be increased or decreased just to help the software make connections from one node to the next. So if your seismic is a little choppy and it's got a lot of noise, increasing the smoothing level can certainly help with your connections. Undersampling is a great tool, especially if you're working in very large data sets. So it's essentially a way of decimating your seismic so that you're not having to read the entire seismic volume, and this can help the process run a little bit faster. Now, you can also undersample in the vertical, but you do want to be careful in this because if you undersample in the vertical too aggressively, you could lose a little bit of your high frequency content, making it a little bit difficult for that polarity, whatever polarity you choose, to accurately pick your events. Now below that, we've come to where we've got our fault sets. So we want to be able to use pre-existing faults, if we have them, to force the software to recognize, to stop making connections across fault planes. So you just drag and drop your fault set into that box. In order for them to display, you want to drop them into the actual image, and then click on that test parameters button again in order to see the outcome. Now, what we should see here is that in many cases, you'll have the termination of connections from one node across a fault plane to the next node. So this can help your fault blocks be way more accurate when you are picking these and editing these. So we strongly recommend using faults if you have them. Now you can pick those within the software, or you can import them if you've already made them in a different software. Let's move on to the Advanced Options tab, where we can now so we can use horizons to restrict where we want that model grid to be created, right? So for instance, if I wanted to just create a model grid, if my area of interest was just this cliniform section here, what I can do is tell the software to only create that model grid between two horizons. And this is a really neat feature, actually, to the ability to just shift those horizons a little bit, which can be useful to reduce the amount of edge effect that you can that sometimes get from the nodes being right at the constraining horizons. And so by using these bounding horizons and resetting my focal point and then saying test parameters, you'll see the software will now only create a model grid between those two horizons. All right, if I zoom in here a little bit, you'll see that there are no nodes outside of those bounding horizons, meaning that the software will only have to read a little bit of the data as opposed to the entire volume. So that might help things run a little bit quicker. You can do the same sort of thing with your multi-Z objects and use those as exclusion zones. For instance, if I were to bring a salt body here and reset my focal point, rerun my test parameters, you'll see that now what will happen is the software will stop the propagation of nodes at that multi-Z object. So this is really great for when you're working in areas with a lot of salt. It'll stop those nodes from propagating into and throughout that salt, or that that geo body, I should say, or that multi-Z body. So this can be really helpful to make really clean terminations of your geo model from your model grid up against salt bodies. Now, last but not least is the correlation threshold. And I think this might be one of the more important parameters to actually be considered. So now the correlation threshold is a parameter that is essentially saying, as long as one node is within a certain percentage of the node next to it, then it will go ahead and make that connection, right? So remember, this is happening in 3D, and so essentially, by lowering the correlation threshold, we can get the software to be much more liberal with the connections that it's making. So if I were to reduce this down to, let's say, 10%, Let's see if I can get a few more connections to be made. All right, so by lowering that correlation threshold, it doesn't look like I was able to get too many more nodes to be connected. I guess that's probably just about as good as it's going to get. However, if we switch that up a little bit and ramp this up to maybe 80% and rerun this, you'll see far fewer connections because the software is going to be much more restrictive in the connections that it's going to make. So you can see we've lost quite a bit of connections down here in this kind of polygonally faulted area. So this is a very important parameter to play around with and run these test parameters before deciding which set of parameters optimizes this initial model grid build before you save it to move on to the next step. So once we've played around with all of our parameters and we've decided and we feel like we've optimized them based on the model grid, go ahead and turn on your model preview. Right? So this is just another way of looking at the eventual geo model that we're going to create. And so as long as we've got a good start, that's kind of all we're looking for. We want to click on save. We can then name this model grid anything we want, or we can let the default name go ahead and stay there and just click OK. And the software is going to run and create that model grid. Okay, when that model grid is finished running, you'll find it in the model grid topic in your project browser. And if you double click on the main topic heading, it'll open up the auto-interpreted version. So you'll see if I were to expand this dropdown, there's two versions here of this model grid. There's an initial grid and then auto-interp. The difference between these two is that the initial grid is just made up of the individual nodes without any connections being associated with those. So there's very few applications within the software we actually want to use that initial grid. That's kind of an advanced workflow that I think we'll cover in a different video. But in your day-to-day work, you want to be opening the auto-interp. So this is the version that has all of the nodes connected and the patches built out into much larger patches. So I'll tile these really quick just to kind of get a good view here. And now let's start talking about how we interact with this model grid. So the main reason that we want to edit or work with the model grid is twofold. The first reason is because it's likely that the software, even though it interpreted the whole seismic volume, it probably didn't do it perfectly, right? And by that, what I mean is if you click on this tracking icon here, right, you'll see you bring your cursor into your model grid window. And if I bring that up to, let's say this is the BCU, you'll notice that if I place my cursor on this BCU, you'll notice it didn't fill it out to its entirety, right? So the first reason why we interact with the model grid is so that we can build out these horizons, right? So in the tracking mode, I'll click once to activate the horizon that I want to begin working with, and then I'll bring my cursor to the extension of that horizon that the software missed, and I'll just click once to kind of piece all these, puzzle pieces together. If you will, you can think of it like a puzzle, where the software has made all the pieces, and now it's your job to go and put them together. So just by bringing your cursor across and clicking once, you'll see you can very quickly build a horizon. Now, the second reason that we interact with the model grid is because not only is the software creating these horizons, it's doing something else at the same time. It's assigning a relative geologic age to every single patch within the model grid. And it uses that relationship to build this relative geologic age volume. So if I come to my properties pane and I turn on my 2D preview, you'll see an overlay like we saw at the initial stage of the model grid. Now you can see here, this overlay, this multicolor preview of my eventual geo model is pretty complete. And you'll notice there's some spots where the software has lost its ability to continue that relative geologic age relationship. So by connecting pieces of a horizon from one side of a fault, let's say, to the other side, so I'll just click once here, is all you have to do. And if I turn on my 2D preview, you'll see now the software has been given enough constraint to build or propagate that relative age relationship further down because I've given it enough constraint for the software to understand that age relationship. So in essence, that is the main job of the interpreter in the software. Now, where this is especially useful is, in this case, down here you'll see in this faulted area. So if I were to bring my inlines quickly over to a spot I'm familiar with and return on my preview, you'll notice that the software has lost its ability to propagate or continue that age relationship down into this faulted region. So what I'll do is I'll click on the M key, right, mic key, to validate the horizon that I had been working on. So clicking on the M key is going to validate and mark that horizon. You'll see that now I've been given a color, a marker for that BCU that I was working on. Okay, so that's one way of validating a horizon, and I think I prefer marking because it just reminds me of the horizons that I've already worked on and maybe some places that I need to continue my efforts. However, what I want to do now is I want to try and get that age relationship to propagate further down through this faulted area. So what I'll do is I'll just begin by connecting up some of these horizons here. And I don't have to give it too many extra spots, and you'll see how quickly I can build this out so that the software recognizes the appropriate age relationship. So I'll go ahead and mark this. I'll turn on my 2D preview, and see that's all I needed to do in order for the software to now fill in all of that, all of those age relationships, right? So this is in essence what your job would be as an interpreter to build out or interpret through your area of interest so that your relative geologic time volume will be accurate for when we extract our horizons from it. Now, I'll say this, you'll notice where there are other places within this seismic volume where there are large gaps where there are no model grid preview, excuse me, there are no geomodel previews. And that is okay. Quite frankly, you don't need to work on the entire model grid. You can just work on your specific AOI and get that into a good space, save your model grid, create a geomodel from it, and then extract horizons in that area. And later on, if you're asked to focus your efforts in a different regional, geographic region, you can always come back to this model grid, start working on this area again, save it, and then create a new geomodel from that. Now, I will say a couple more things about the model grid before we move forward. You'll notice on the left-hand side of my model grid is the horizon list. So this is just a way for you to go very quickly to any horizon. You can sort these by area. You can sort these by marked or unmarked. Right? So if I wanted to just see my marked horizons, I can see just the two horizons that I marked here, and by clicking in my horizons list, I can highlight those and bring those back up for editing if I wish. Additionally, if you don't want that in your view and you don't feel like you really need to work with the horizon list, that's fine. You can always collapse this. However, there's one other thing that you may find useful is that by having this horizon list here, by right-clicking on any of these horizons, you do have the options to save these out as their own specific horizons. So just right from the model grid, you can create complete horizons and then save those individual horizons out by interacting with this horizon list. Now for this video, we're working more toward the creation of a horizon stack from our geomodel, so I'm not really going to go into that process. Needless to say, I'll go ahead and close this horizon list and let's start talking about some other things. For instance, so far, I've only showed you how to pick on an inline, right? Very easy to switch and change to a cross line. For instance, if you feel like your horizons may be propagating or they're more easily picked in a cross line, simply click on your seismic window and then come to your volume manager and change from inline to cross line. Okay, so besides the ability to edit your model grid in the inline and crossline direction, we can also edit on a 2D line by clicking on the new interviewer icon and selecting new 2D line interviewer. We'll select a pre-existing 2D or arbitrary line. The software will map that 3D data onto the 2D arbitrary line. And just like we did with the inlines or cross lines, we can now map on our arbitrary line. Now, one thing that's important to note is that the model grid was picked very specifically for a unique polarity set that you determined that we talked about in that model grid. Because of that, whenever you activate a horizon, in this case, I've activated an inflection down. Once you've activated a specific polarity horizon, the software will only allow you to connect patches of similar polarity to that, right? So typically, that's fine. You know, you're going to want to, you know, make sure that you're building a horizon on a trough or a peak, and you want to connect other peaks and troughs to that. However, for large regional projects, or where you've got a number of phase changes, sometimes it's useful to be able to connect patches that have different polarity. And you can do that by first selecting the patch and then come into your properties pane, and you'll see if you come down here to the polarity, you can turn off the polarity. Now you'll get barked at. There's a window is going to pop up and it says this isn't recommended, but that's okay. We'll go ahead and say okay, and you'll see now the software will let me pick any polarity I want to add on to that horizon, right? Now this is another opportunity to show you something which is called a conflict. So you can see instead of just a yellow horizon popping up, now I've got my tracking mode on and I'm moving around and I'm seeing a gray and a pink patch kind of pop up. Well, what this is telling me is that there's a conflict between the active horizon, which is in yellow, and the patch or the horizon that I'm trying to connect it to. So the gray portion indicates the parts of the new patch that are available without conflict to be added on, whereas the pink parts are showing the areas where there's a conflict. Now, if I choose to force the model grid to make that connection, even though there's a conflict, I have two options. I can do a partial reconstruction or a full reconstruction. The difference is essentially geographic, right? So the partial reconstruction is going to work in a smaller area, whereas the full reconstruction is going to just add everything on without any type of consideration to spatial locality. So if I say, I'll just go ahead and say a full reconstruction and click apply, you'll see the software is going to go ahead and build out that horizon based on the connection that I was trying to make. Now I'm going to go ahead and turn the polarity back on just so I don't forget to do that later, but always remember to go ahead and turn that polarity back on, because if you leave it off, it could get you into some trouble. Sometimes, even after we've been very careful with our connections, we may find an error, and we can use what's called a horizon eraser to take care of that. And there's two ways to do that. If I want to just erase a certain part, I can click on the horizon eraser, and you'll see my cursor changes to this little circle here. All I have to do is hold down my primary mouse button and drag my cursor across the portion I want to erase. Now, another way of doing that is without having to change from my tracking mode, I simply hold down my shift key. So that's the hotkey for going to the eraser, and then just hold down my primary mouse button and drag it over the portion I want to erase. I can erase in both the seismic window, and I can also erase from my horizon window. Another unique tool we have in the software is the ability to map data onto patches within your model grid. Now, typically, when we begin editing our model grid, you'll see that the patches, of course, are displaying in your horizon viewer as the Z value. And so if I click once in my model grid window to activate a horizon and then start building that patch, you'll see in my horizon viewer that, of course, the Z value is being displayed. Instead of the Z value, what I can do is map certain attributes onto these patches within the model grid. To do this, click on Data Mapping on Patches and select the first option. We can map either standalone attributes or real-time attributes. I'll select the RMS amplitude, so they must be pre-existing. We'll click Next. I'll name this RMS and click Run. When the process finishes running, click on your Horizon Viewer window, and in the Properties pane, click on Display Mode and change it from Z value to Data. You'll see the display change in your Horizon Viewer, And if you go to your model grid window, you'll see now as we build this patch out, instead of seeing the Z value, we now see the RMS amplitude displayed. So this is a great technique that we can use to notice specific trends, and in this case, a high RMS amplitude value, which indicates that we are following the correct horizon and that our picks are accurate. Let's move on to creating the Geo model. After you've spent a bit of time interpreting your seismic, it may look something like this. Now, I've interpreted this thing from mudline to basement. You probably wouldn't have to do this like I mentioned earlier. You want to focus on your AOI. But in this example, I'll just zoom in a bit. And let's say I've spent some time and I'm going to turn on my 2D preview. And I'm going to look at that and I see that my GeoModel preview looks like it's following my seismic really nicely. I feel confident that I can move forward with the GeoModel process. There's one thing I like to do that's going to be really useful for getting a really perfect, really nice GeoModel built. You'll notice in this area here, there are a few small gaps, and I'm not too worried about, because what I'll do is I'm going to set a focal point here. And if I come to my properties pane, you'll see I have some options under the quality. If I click on quality, by default, it's set to medium. What I like to tell people is that if you work and interpret and you get your preview looking good with the medium quality preview, before you create the GeoModel, change the quality to high. Now that's going to make a bit of a smaller window, but you'll notice already those little gaps have already been filled in. And the reason they're filled in is because the high quality preview is more indicative of what the GeoModel is actually going to look like, because it utilizes a number of additional parameters that the medium quality preview doesn't. And those two additional parameters are the interpolation size and the smoothing level. So what we can do is actually interact and change the interpolation and smoothing level here in the properties pane, and then reapply the 2D preview to see how that changes things a little bit. Now this is more of a fine tuning kind of step, but the idea here is that you want to play around again with these final parameters until you get your GeoModel looking really, really nice. And the reason why this is so important is because now watch, we're ready to move on to the next step. We're going to come here to my GeoModel creation, say compute GeoModel, and if you'll notice, the software takes those values right from the properties pane and inputs them in my GeoModel creation. So it's saying, hey, I know you've played around with the properties pane and you've got some really fine-tuned values that you want to use. So I'm just going to move those in there, and that's the values we're going to use to create this GeoModel. Now, the very first line is the marked horizons. It says no fit. If you click on that, you'll see you've got two options, either fit or no fit. If you've marked a bunch of horizons and you feel very comfortable that they're perfect, they're right on, they're perfect and accurate, you can say fit, and that means an interpolation and a smoothing level will not be applied to your marked horizons. However, if you want to allow the software to add a little bit of interpolation or smoothing to those marked horizons, you can change it to not or no fit. Now you'll want to use your faults again, because we want to stop the software from interpolating across my fault planes. So be sure to use your fault sets again. Likewise, be sure to use your exclusion zones, because you want to stop that GeoModel from interpolating into your exclusion zones. And then click on the button Save. Give your GeoModel a name and click OK. The software will run and the new GeoModel will be created and placed in your project browser under the volume topic. So to find that new GeoModel, be sure to change your topic to volume in your project browser. Go ahead and scroll down and you'll find your GeoModels under the model folder. Show you guys a neat technique for QCing that GeoModel. So I want to interact with my two-channel blending tool. So up here is the two-channel blending viewer tool. I'll click on that and I'll select the two-channel volume blending viewer. I'll drag my seismic I used for the model grid build into the first channel and the GeoModel into the second channel. I can adjust the colors here, make this a little more, heat this up a little bit. I can change the color scale for my GeoModel. I'll zoom in and you see I've got this transparency slider here. I can change the transparency up or down. And essentially what this is useful for is really zooming in and making sure that my geomodel is following the structure that I see from my seismic. So this is a great QC tool that you want to use just as a last step before moving forward with your horizon stack extraction, which is the final step or the final topic we'll be discussing in this video. Where you don't like the geomodel preview and it's not following the seismic, you would want to go back to your model grid, edit the model grid, create a new geomodel, and then do this QC step again. So at this point, I'm going to say I like my geomodel and I want to create a horizon stack from that geomodel. So I'll change my toolbar from model grid to horizon stack. I'll click new 3D horizon stack. I'll select the geomodel I want to use as an input, and then I'll display the seismic on top of it. But I like to make a point that just to make sure everyone is aware that we are actually going to extract horizons from the age relationship from the geomodel and not from the seismic. We just display the seismic because we're used to looking at seismic. On the right-hand side of this window, we use the sliders to set the upper and lower boundary of where I want that horizon stack to be. And then I'm going to decide on how many horizons I want to slice that interval into. I can make a determination by turning on my Horizons Preview tab to see what that slicing of the geomodel would look like. If I want to increase the density, I just change that in the number of horizons window, or I can decrease it. Once you determine the number of horizons you want to slice that geomodel up, click on the blue arrow on the right-hand side of this window. And that'll bring us to our attribute mapping portion. So the software is going to use those horizons as a template to map attributes onto. So you'll click on the filter dialog box, and you see we've broken up all of our attributes into some parent topics. I'll just say RMS amplitude. So I'm going to map the RMS amplitude from a specific seismic volume onto that horizon stack. Because it's a windowed calculation, I have to determine the window size. And in this case, I can either center it on that horizon or look for samples above or below. I'll just say centered. I'll give this a name. And if I wanted to, I could click run, but I'd like to note that if you know that you want to do a number of different attributes, you can click on this plus tab to the right of attribute 1 and set this up as a batch mode. Now when I click run, it'll do both the RMS and the spectral balancing together. To open a horizon stack, switch your project browser to Horizon and double-click on the horizon stack you wish to open. I like to display a volume, a seismic volume, just to see the intersection between the two. By placing my cursor in the horizon stack window and rolling my scroll wheel, I can scroll up and down and you can see that intersection of the seismic and the horizon stack. One nice feature of our horizon stack is the ability to turn on auto contrast. This will recalculate the data range for each horizon stack slice so that you don't have a large degree of variation jumping from one horizon to the next. Another neat tool, or option I should say, that works for many windows is the ability to quickly display a 2D view in 3D. If I want, I can click on this icon and select Display 2D View in 3D. By linking the two viewers, you'll see that anything I do in my horizon stack window is mirrored in my 3D stack. I'll do the same with my seismic to set up a really quick and easy display. In conclusion, you can see how spending a little time in your model grid to geomodel editing stage is going to help you get a very accurate geomodel and horizon stack extraction from it. I hope you enjoyed this video and thanks for checking it out. If you have any questions about the software, please shoot us an email at support@elise.fr, and we look forward to seeing you in the next videos. Thanks.